Okay, now we will have two examples of fx using Fourier transform series expansion. Okay, so two examples. For fx, one example for fx is a constant function. So case one, constant fx equals to 1. Okay, so this fx is equals to 1 is a constant function, is also continuous between x belong to 0 to L. The only thing this fx is not satisfied for the boundary conditions. Okay, so this is constant function not satisfy boundary conditions. Let's see if we can use this Fourier series expansion to represent our fx. So as we mentioned that fx equals to 1, my yn is equals to sine n pi x over L, where n starts from 1, 2 until infinity. And we have our fx can be represented by sum from n from 1 to infinity bn sine n pi x over L, where this bn is equals to 2 over L, 0 to L, fx times sine n pi x over L. So those are all the conclusions from our previous derivative. If you don't understand about of them, track back to the notes, okay? And when my fx equals to 1, so this equation becomes 2 over L, the integral from 0 to L, sine n pi x over L. This is integral over dx. Then we can get our integral, which is 2 over L, and this is L over n pi. And the sine integral will be the cosine part. This is n pi. Okay, will be minus cosine n pi x over L, and that is the integral from 0 to L, right? That is the integral, and then you can just simplify these equations, become 2 over n pi. Okay, so L cancel out, and the integral, which is the minus cosine n pi x over L from 0 to L. When the x equals to L, this part become n pi, so it will be minus cosine n pi. Okay, and that is when x equals to L minus cosine 0 when x equals to 0, and cosine 0 will be equals to 1. So minus 1 will be plus 1 there. Will be 2 over n pi. Will be 1 minus cosine n pi. Okay. And this cosine n pi, when n equals to even number, so cosine n pi, when n is even number, for example, 0, 2, 4, 6, that will be equals to 1. When n is odd number, for example, 1, 3, 5, 7, so it will be cosine pi, 3 pi, 5 pi, 7 pi, that will be minus 1. So this cosine n pi will be equals to minus 1 to the n. Okay, minus 1 to the n, that will be equals to cosine n pi. And then when you put this cosine pi n pi into my back, the bn part, my bn will be equals to, when n is out. So that will be -1, that will be 2. So 4 over n pi. And when n is even number, that will be 1 minus 1 will be 0 for Bn. So my fx in the end will be represented by a sum from n equals to 1 to infinity, 4 over n pi, right? 4 over n pi sine n pi x over L, where the n is equals to only the odd number. So 1, 3, 5, 7 until infinity. That is how you can represent fx equals to 1 using generalized Fourier series, which is 4 n pi sine n pi x over L. So this is your orthogonal basis size. This is your Bn, which is solving by this analysis. Okay.